All right, let's talk about how to construct the partial fractions decomposition of a rational function. For this example, we have 2x over x minus 3 quantity squared. This is a repeated root, and so when I have a repeated root, this produces multiple terms. I'll have a term that has x minus 3, and then another term that has x minus 3 squared. So that's the rule that I use if I have a repeated real root. On the numerator, it'll just be the standard form for the numerator, just a constant. The degree of the numerator will always be less than the degree of the denominator. All right, so we have to solve for this. The standard technique here is we'll clear out the denominator. So multiplying by x minus 3 squared, we get 2x is equal to a times x minus 3 plus b. And then we need to solve for a and for b. For this, there are two ways of solving this that make sense. And I'll do this in different colors. So method number one. And method number one always works. It may not be the easiest method, but it always works, is to multiply out. So I have 2x plus 0 is equal to ax minus 3a plus b. And then I'll match the parts. So the linear part here matches the linear part here, so a is equal to 2. And then the constant term here matches the constant term here, negative 3a plus b equals 0. So I have a system of two equations and two unknowns that I must solve. Clearly a is equal to 2, and if a is equal to 2, then the bottom line becomes negative 6 plus b equals 0, for b is equal to 6. So that's one way of solving it. A second way of solving would be to use substitutions. And so if we let x is equal to 3 in the top of line here, I would have 6 equals 0 times a plus b, so that b is equal to 6. Now there's nothing else obvious to plug in, but I could plug in literally anything else. So let's plug in something simple like 0. On the left side, I would have 0. On the right side, I would have negative 3a plus b. And so this would produce negative 3a is equal to negative 6, so that a is equal to 2. I get the same answers both ways. In this particular example, it's a toss-up as to which one's easier. But in any event, I get my a and my b. And so my final answer is that the decomposition is 2 over x minus 3 plus 6 over x minus 3 squared. And this can be checked by getting a common denominator and confirming that these would combine to be 2x over x minus 3 quantity squared.